So, you're welcome to today's tutorial on tabular integration by parts. So, in some examples that we saw in my last two videos about repeated integration by parts, we solved some examples, let's say yes, of which we applied the integration by parts formula 2 times. And at the end of the day, we solved for the value of whatever integration that we wanted to. And as you can see, we got something here, extra term here, we got another one here, we got another one here. All right, so let's look at something here. Now the tabular integration by parts assume that when we have a function f of x and it is being repeatedly differentiated easily to a derivative that is eventually 0, the function g of x can also be repeatedly integrated easily, right? Whatever we are trying to say here is that whenever you want to apply integration by part, means that you have two different functions multiplying together. So if this function is being differentiated in order to eventually get to 0, for example, when you have x squared, let me bring it here. For example, when you have x squared and then exponent x, and I'm able to differentiate this and I get 2x, and my next integration by part differentiate and I get 2, it means that I don't have any x component here. So any exponent component which is being attached to it will be easily to integrate without applying any further integration by parts. So in this case, we can use the integration by parts more than once to evaluate this integral. And we are going to do that in a tabular form. And this, I think you'll be happy to know this and add it to your toolbox. So now the tabular integration by parts. Let's pick an example. Example 1. Evaluate integral of x power 3 exponent x dx. Let's solve it algebraically and then use the tabular approach to see how quick we can get it up. So in doing this, let's apply whatever you want to do. So using our previous knowledge in integration by parts, we can say that our u equal to x power 3 and our dv equal to what? Exponent x dx. As I said, later on I'll bring you some techniques on how to choose your u and your dv when you encounter some functions combinations. So in doing this, you'll be able to come out with your dv, your du, and your du dx is going to be 3x squared, and we are going to get dv equal to 3x squared dx, or du, sorry, we are dealing with u. And our dv here, when we integrate both sides, we are going to get exponent x. So in doing this, applying the formula u dv equal to uv minus integral of v du, we are going to get integral of x power 3 exponent x dx to be equal to x power 3 exponent x minus integral of exponent x multiplied by 3 x squared dx, which is the du, right? So this is what we have. So in simplification, we are going to get x power 3 multiplied by exponent x minus the integral of 3x squared exponent x dx. Now you can see that this type of integration, the power of x is being reduced by 1, and therefore it's simpler than this original function. That means we are on the right track. So we can have one equation here. So let's do further analysis. Now we need to evaluate the integral of 3x squared exponent x dx. And now doing that again, we can assign our values to them, and when we assign our values to them, we can say that let's our u equal to 3x squared again, and our dv equal to exponent x again. Therefore, our du is going to be 6x dx, and our v, which is the integral of both sides, is going to be exponent x. Putting them back into the function, formula, we are going to get 3x power 2 exponent x dx, which is equal to 3x squared exponent x minus integral of exponent x multiplied by 6x, which is our du or dx. And in this case, we are going to get 3x squared exponent x minus integral of 6x exponent x dx. This is another one that we have gotten. And now we need to, you can also see that this one, the x power, which was 2 when after doing this, has been reduced to 1. And it's far simpler than the original one that we integrated. So now let's do our last analysis over here by applying another integration by parts. So this falls under the repeated integration by parts. So in doing this, we can say that our integral of 6x exponent x dx. Now we can say that let our u equal to 6x and let our dv equal to exponent x. In doing so, we can say that our du is equal to 6 dx, and our v, which is the integral of both sides, it's v equal to exponent x. And in doing so, you can place them back into the formula, and we are going to get 6x exponent x dx, which is equal to 6x exponent x minus integral of exponent x multiplied by 6 dx. So in simplification, we are going to get 6x exponent x minus integral of 6 exponent x dx. So now integral of 6 exponent x dx becomes the same 6 exponent x dx. We are going to get 6x exponent x minus 6 exponent x, and then don't forget your plus c. So now we have one formula here, another formula here, and then we got our last one here. So by combining our formulas, which is instances 1, 2 and 3, so let's see, this is 3, this is 2, and this is 1. What are we going to get? Let's see, for the first one, we have x power 3 exponent x, x power 3 exponent x, and now minus the integral of 3x squared exponent x dx, and the integral of 3x squared exponent x dx was also calculated over here, of which we resulted on this, right, which is 3x squared exponent x, which is what? Minus into bracket 3x squared exponent x, and then minus 6x exponent x, minus 6x exponent x dx. That is the integral dx. And then let's simplify it before we add the other one. So x power 3 exponent x, when we simplify this, we are going to get negative 3x squared exponent x. Negative times negative will give us positive, plus integral of 6x exponent x dx. So getting this, we know that our 6x exponent x dx, we also have its simplification here, which is 6x exponent x, which so now we are going to get x power 3 exponent x minus 3x squared exponent x plus, and then the result is 6x exponent x minus 6 exponent x, and then plus our c. So this is the result of whatever we are getting after combining all the three functions. So as you can see over here, there's some trend inside. So if you are not more focused and you are doing this repeated integration by parts, you find yourself wanting. And in this case, using the tabular approach or tabular integration approach will be able to help you a lot. So this resulting answer that we have gotten by integrating this question, x power 3 exponent x dx, we can do that simply by applying the tabular approach. So as you can see, the first term is positive, the second term is negative, the third term is positive, the second term is negative, and then so on. So in this case, when we are doing the tabular approach, you need to draw your table, and then per the table, what you can do is that here you have f of x. The first one is f of x, so has your first function that you have assigned it to you. Here is your predicted sign. That's the trend over here. Is it going to be negative? Is it going to be positive? And then the next one is your g of x. So your g of x is going to be the repeated integral. And then your f of x is going to be the repeated derivative. Yeah. Now the one that you find the derivative is always the u value. So let's assume that here's our u value and here is our dv. That's what I've represented as g of x and u of x. So based on that, our u was x power 3. Our dv is x exponent x. So based on this, when we did the first integration, we need to do the integration in such a way that the integration will eventually get to 0. So now my first integration, I'm going to get 3x squared. My next integration, I'm going to get 6x. My next integration, I'm going to get 6, and my next one, I'm going to get what? 0. Because when I integrate, differentiation, I'm going to get 0. So always the first one is plus, minus, and so on. Because here is negative 0, I don't want to bring any sign there. And then here, when you integrate it, we are going to get the same throughout. So far as you get the derivative to be 0, you need to stop there, the iteration there. And what you need to do is that you pick the first one, you match it to the second one of the integral. You match it to the second and next one of the integral. You match it to the next one of this integral. You match it to the next one of this integral. So the simple trend is that we leave the dv, we leave the first one, and then the u, we leave the last one. And at the end of the day, this means that we are multiplying this first one of the u to the second one of the dv, the integral of the dv. And at the end of the day, we are going to get x power 3 multiplying by x exponents x. And don't forget that the first one has a positive power. The second one here will have a negative power here. Negative power here, right? Second one here will have this second one here will have a negative sign here. So it's going to be negative 3x squared multiplied by exponent x. The next one, which is what? The 6x will have what? A positive, which is plus 6x multiplied by exponent x. And then the last one is 6. We'll also be having what? The 6 will also be having what? A negative, which is what? Negative 6 exponent x. And then plus our c, which is because it is indefinite integral, and this is the result, the true result that we have gotten. So as you can see, let me move on. So you can see the true result here. The true result here, they are the same. They are the same. So this is the tabular approach. So instead of going through all this, repeated integration by parts, you can just do the tabular approach. When you get your u and get your v, dv, put them on a table like this. So this is my u from the question, it's x power 3, and this is my dv, exponent x. Differentiate the u till you get to 0, and then integrate the dv till you get to the same number of where you stop with the differentiation. And then from there you do this, cross this, and then you tally the sign with this, you tally the sign with this, you tally the sign with this, and you tally the sign with this, and you'll be good to go. So this is the tabular approach, and I know, or I believe that this is very simple approach, and use it to try other examples, and I know that it will help you a lot. So use the tabular approach. This is a trial question. This is a trial question, so use the tabular approach. To evaluate the integral of x power 4 multiplied by the exponent 2x or dx. And then, if possible, use a repeated integration by parts to check your answer as well, or a calculator to check your answer as well. Thank you for watching.